Right guys, now let's work on this particular formula, which is very important, and a lot of problems are based on this, which generally come in the examination. So let's be a little more careful while working on this. All right, now we have a tan of a plus b, right? So it goes like tan a plus tan b, 1 minus tan a tan b. All right, let me just write this formula once again. Tan of a plus b is tan of a plus tan of b by 1 minus tan a tan b. Okay, now let us just make a little bit of changes. Let me write a as, let's say, a as pi by 4. See what happens to my problem. That becomes tan of pi by 4 plus b, and the right hand side I'll get tan pi by 4 plus tan b by 1 plus tan pi by 4 tan b. So what happens to this guy? It gets 1 plus tan b divided by 1 minus 1 into tan b, yes, and now it goes like 1 plus tan b divided by 1 minus tan b. Okay, that's all about it. Very simple. This is tan of pi by 4 plus b. Okay, that's what we have, isn't it? Now if my question is somewhere looking like this, that I have if I put tan on the other side, it looks like pi by 4 plus b, or whatever it is, it looks like tan inverse of 1 plus tan b by 1 minus tan b, and in more general terms, based on this, okay, based on that, they can make a question which can look like y is equal to tan inverse of 1 plus x by 1 minus x. Okay, this is the question which is actually based on this formula. And how does it generate? Basically, I take the first guy as pi by 4, and I can see that this guy becomes 1, and overall I get 1 plus tan b and 1 minus tan b, and I'm taking this and this as x and x, so that converts a problem like this. Now how will I solve this guy? Keep this in mind. Okay, this is a part, this is how it generated. Now if this was my question, how will I solve this guy? I can see this this guy has to look like tan a plus tan b 1 minus tan a tan b. Okay, so that the tan inverse outside has to cancel with something in tan. So keep that in mind. The first thing which we learned, if there is a tan inverse here, this whole thing has to become tan, so that I can cancel the tan and the tan inverse. This is what we generally think, right? Now how is it possible? That is the formula, and the only formula. All right, so let's go ahead. I have tan inverse of, I'm taking x as tan theta. So what happens here? 1 plus tan theta by 1 minus tan theta. Now is this guy looking like this formula? Not yet, because I don't have a tan here. I need tan a plus tan b. So can I write this guy 1 as tan 45? Yes. Tan inverse, I can write this as, I can take 1 into tan theta here, so that I can substitute for this and this both. That is tan 45 plus tan theta divided by 1 minus tan 45 and tan theta is what I have, correct? Now is this guy looking more like this? Yes, tan a tan b, 1 minus tan a tan b, it looks like that. See now what happens. I can write this as y is equal to tan inverse of tan pi by 4 plus theta. Yes, now I can see very simply that tan inverse outside can be cancelled with tan theta inside here. So what happens to my problem? It becomes y is equal to pi by 4 plus theta. Now who's theta? This is what I'm supposed to differentiate, but my problem should be in terms of x. So who's theta? From here, theta is nothing but tan inverse of x. So theta is tan inverse of x. I just put theta on this side. So I can write y is equal to pi by 4 plus tan inverse of x. So differentiate this guy, dy by dx. This guy is differentiate. 0 is constant, and 1 by 1 plus x squared is what I have. I can write 1 by 1 plus x squared. This is dy by dx. Very simple. And this whole thing was based on tan of a plus b. All right, let me just write that. So they can ask a question which looks like y is equal to tan inverse of 1 plus x by 1 minus x. All right, anything else they can ask? Yes, they can ask anything like this. Y is equal to tan inverse of 1 plus whatever function by 1 minus same function. Anything which looks like this, a general format, I should take this function to be tan theta, and this has to be like tan 45. That's it. So let me do some more problems based on this second type, where this was the general thing that this guy was x and x, and I took this x as tan theta. Now what if I have another problem which looks like, let's say y is equal to tan inverse of, so he's giving you something like 1 minus e power x by 1 plus e power x, some function, all right? But I got to make this guy look like, see, if there's a tan inverse outside, this whole thing has to become tan. How can this become tan when you have e power x? First of all, I should not have e power x, right? And I should have a formula which is looking like this. So I'll take this guy e power x as tan theta, very simple. So what happens here? So y is equal to tan inverse of 1 minus tan theta by 1 plus tan theta, very simple, isn't it? Now let's go ahead. If that's the question, so what happens here? I can write this 1 to be what? Tan 45, tan pi by 4 minus tan theta. I can take a 1 here, that is 1 plus tan pi by 4 tan theta. Why am I doing this? Just because I have a tan inverse outside, and this whole thing has to become tan of something, and that can happen if at all I have a formula like this. That is tan a plus tan b, 1 minus tan a tan b. This 1 is important, so I'm not doing anything here, correct? So if this is a minus, let be a minus, not a problem. I have another formula which is tan a minus b is tan of a minus tan b, 1 plus tan a tan b. That's it, correct? So this guy looks like more this formula. Now what happens to this? Tan inverse of, I can see this is tan pi by 4 minus theta. So now can I cancel this? Yes, I can cancel it off, and y is equal to tan, or I know tan is pi by 4 minus theta. But who is theta now? Theta can be got by this substitution here. If I put tan on the side, I get theta is tan inverse of e power x, and now if I differentiate this guy, I get my answer. Very simple. Generally, if nothing here, only x here, so I'll take x as tan theta and solve it like this. Or if at all I have a function instead of x, I just took that function as tan theta, so that I can get tan a tan b, right? That formula, tan a plus tan b and 1 minus tan a tan b. Okay, anyway, let's continue this problem. Y is equal to pi by 4 minus theta was tan inverse of e power x. Yes. Can I solve this? It goes like differentiation of a number is 0 minus 1 by 1 plus e power x the whole squared. It's a chain here into d by dx of e power x, and that goes like minus 1 by 1 plus e power x the whole square into e power x. That's my answer. Differentiation of e power x itself. That is it. Yes. Now keep this in mind. We'll have a small shortcut which can also help you in CET problems where I don't have time to do all these things, but still, can I write the answer directly looking at the question? There is a way. Right, now let's say this problem was not e power x, and here we have log x. Okay, we have some other function, let's say log x. Now what happens to my substitution? See, I just need to make sure that this guy has to become tan, so this has to be anyway tan theta, so I'm just writing log x as tan theta, and my substitution, I can write theta as tan inverse of log x, and that's it. This goes like that. Log x is tan theta now, so it's the same thing. This is the problem. That's how it goes. 1 is tan 45. The same procedure follows. I don't have to do anything. No difference in this. All right. Only while substituting, and I get pi by 4 minus theta. Yes. While resubstituting theta, this becomes tan inverse of log x. And when I differentiate this, I'll get what? I get 1 by 1 plus log x the whole squared into differentiation of log x, and my answer would be log x the whole squared into 1 by x. Very simple, right? So something else comes here, so something else will come here, and the same thing will come here and just change. That's it. So what is a shortcut? If at all I have to do this whole problem in, let's say, 5 seconds. Okay, my problem was log, not log this time. Let's say I had a secant x. Can I write the answer? All right, I have a secant x, so we can skip all these things and see what the answer would be. I will just take whatever is here as what? As tan theta, and theta is what? This guy, isn't it? Now if I keep changing, can I write the answer without even doing this? Yes, just differentiate this guy. Just differentiate this guy, because eventually I need to substitute theta here and differentiate, right? So the answer here would be differentiating theta as what? I just differentiate tan inverse of log x, and that's it. Okay, it's not log x, it's secant x, because I took secant x. Yeah, right, secant x. Differentiate this guy with a minus sign, so it goes like minus 1 by 1 plus secant x. Yeah, sorry, 1 plus secant x whole squared into secant x tan x, and that's it. that is my answer. Well, let us work it out and check. Yes. So if at all I take secant x as tan theta, this is my substitution, this remains the same. So what happens here? This would become secant x, this would become secant x, and I got to differentiate secant x. So what happened? The same thing is here. That is secant x whole square and differentiate of secant is secant x and tan x. That's it, isn't it? So it is enough that I can just take my substitution here, that this is tan x, and take theta, whatever it is, and differentiate this guy. That'll be your final answer. That's all about it. Okay, if at all I had, let's say something else here. Let's say I had root of sine x, so, and root of sine x. So I'll just take root of sine x as tan theta, and what happens to theta in substitution? Theta is tan inverse of root of sine x. So what will be my answer? If I have to do this in 5 seconds, I just need to take this as root of sine x is tan theta, and theta is tan inverse of so much. My answer would be differentiation of this with a negative sign. If at all there's a minus sign here, and there's a plus sign here, is a positive sign. So what would be my answer? Shortcut. If I have to differentiate this guy with minus sign, there is minus, differentiate this guy 1 by 1 plus root sine x the whole square into d by dx of root sine x, and that's it. So it goes like minus 1 by 1 plus, I can cancel this, that is sine x, into 1 by 2 root sine x into cos x. So that's your answer. Hardly takes 10 seconds to solve this. This can be a CET question, alright? So these are the shortcuts we need to know while doing differentiation of this typical substitution problems. If you can remember this general format where you have 1 plus some function and 1 minus some function, this function has to become tan theta, and you can write the answer directly just by substituting whatever theta you get, alright? That's the shortcut.